Grüezi YouTubers, here is the guy with the Swiss accent.
Here is a new mailbag with the different packages which arrived over the last weeks. So let's start. This time it will be without my Swiss Army knife because I unpackage the things off camera. Like that we gain a little bit of speed. This is a 64x32 LED screen and it should be RGB. It looks quite nice, small little LEDs here and also quite a nice PCB here. And I got this cable, I assume it's a 5-volt supply, and this cable here to connect it to an microcontroller. But of course this is not how I will do it. I will probably build my own connectors. The next are two LoRa modules. They are quite small and they are the same as this one here. The difference between the Hope RFM95 and this one is that this module, this rack 811 module, has, in addition to just a LoRa module, it has also a microcontroller, and we should be able to control these much easier just with AT commands. I will do a video about these modules in the next time and test if we can connect quite simple to LoRaWAN. Because if this is possible, then we do not need to bother with the programming of TTN functionality. We just can use this to connect to LoRaWAN and concentrate on the rest of our sketch. There is not a big price difference between this one and this one, so if it works, this could be a good deal. This is an Orange Pi PC. And it is the bigger brother of this smaller Orange Pi Zero. We looked at in one of the last videos or mailbags, and this one is really very much the same as the Raspberry Pi. Same form factor, same GPIOs, even display port, and here also HDMI. But the price is lower. It is about $25, and it's also available at Banggood, I think. So let's quickly check out this Orange Pi PC. The first thing I discovered was that the micro USB connection here cannot be used to power up the board. It has here a DC jack, and then the next thing is I discovered that this is not a normal 5mm jack, it is a smaller one. This is not very nice, but fortunately I had a few of the smaller connectors laying around because I once ordered them wrongly, and now they are very valuable because now I was able to produce a cable with a USB connector on one side and this smaller DC jack on the other side. So at least I can run this Orange Pi. So if you buy one, make sure that you also order a 4mm jack.
After connecting power, it starts to boot Armbian, and after a while it ends in the desktop. It draws about 600 to 800 mA of power. But unfortunately, the display disappears from time to time and reappears after a few seconds. So in contrary to the Orange Pi Zero, which worked quite fine as a MQTT broker, I am not sure if this is a real challenger of the Raspberry Pi 3, because it seems that the software is not yet completely finished.
Next are nice LEDs, but they are a little bit special. Not the normal ones, they are much bigger. If we compare them with the normal 5mm LEDs, they are much bigger, and I can imagine that they look nice in some situations. They come in 5 different colors: white, blue, green and red, and of course yellow. Now of course we test them quickly and compare them with a 5V and a 3V LED. All are blue, and I connected them to about 10 milliampere. And let's check here. You see that the bigger one is not brighter than the smaller ones. I think the smallest is the brightest. Now we can check the forward voltage, if they are similar or the same, because I think maybe there is exactly the same chip in all 3 of them, just the housing is a little bit different. So the forward voltage is 2.87. The 5mm has 2.78, and the 3mm has 2.76. So the forward voltage is very similar. Now check the forward current. We have now about 3.3 volt, and we have 22 milliampere with the 3mm. The 5mm has about 20 milliampere, so very similar, and the 10 has only 16. So maybe I go up and try a little bit more. And you see it will not get brighter, so I think about with 36-40 milliampere it is the brightest, and afterwards it just gets warmer. Though they are somehow comparable, probably a little bit different. Maybe it's really a different chip inside here, but they are comparable, and from a brightness point of view, this one is less bright. I think the same amount of light is distributed to a bigger surface. That's a nice addition to my other LEDs. This is a temperature sensor kit to measure temperature with a microcontroller, consisting of mainly 2 parts. One is the temperature sensor, and the other one is a MAX6675 chip, and we can connect temperature sensor to this device, and then we can measure temperature with I2C. This module will be a part of the project for a soldering iron, a homemade Weller soldering iron. I think I showed you already this part of a soldering iron, and there is a temperature sensor in it here, but I want to use this MAX6675 chip to measure the temperature inside here. And I thought I buy it including a sensor, because you never know, maybe I can use it somewhere else. These are 2 devices which are somehow similar. Just a different shape and also a slightly different value. These are so-called voltage protectors, and what they do is they create a signal. This one creates a signal if the voltage is below 3.3 volt, and this one creates a signal for a voltage which is below 4.5 volt. Now you can imagine why I bought these. These are for the Raspberry Pi, for example, a shutdown protector. I used there a different method. I used a gauge to measure the voltage, and these are quite small devices and they are cheap and simple to use. So now I want to test these voltage detectors, but unfortunately this is okay for breadboard friendly, but this is SMD. And this cannot be used very well on a breadboard, but fortunately we have a solution for that, and this is this small PCBs where we can solder one of these voltage detectors on it, and now it is breadboard friendly. Now I connected the input to this voltage, so we have 3.9 volt input voltage and the output voltage is here. It's practically zero. And now I increase the voltage, the input voltage. And at about 4.5 volt, it immediately jumps to 4.5 volt. If I go back, well, just below 4.4 volt, about zero. And this is this function of this small chip. It has a threshold voltage of 4.5 volt, and we can use this to protect our Raspberry. We can now replace this gauge here by such a small device here. Now let's check out the other one. What happens here? I have connected it exactly the same way. And by the way, this resistor is important. It's a pull-up resistor. Now it's pulled up to the input voltage, and we will see later on how we have to connect this in a Raspberry Pi environment. But now 4.6 volt, I go down, 4.5, we still have the switch on, still on, still on. And now it's off. So this threshold voltage is about 3.2 volt, 3.25 volt. Actually, it's rated 3.3 volt. So this is a 3.3 volt detector, and this is a 4.5 volt detector. You can get them also in different voltages like 2.7 and so on, but I did not find them. So I have a 3.3 volt and a 4.5 volt. Here we have the diagram of these KA75XXX voltage detectors. They all look the same. They just have different threshold voltages. They have an input pin, a ground pin, and an output pin. Now first we connect the input to the USB cable or to a battery, which is about 5 volt, just the voltage we want to detect, and then we connect the output to our Raspberry GPIO. If you connect it like that, this signal will always be 0 volt, because we only have a transistor which can connect to ground, but if this is closed or open, it will always be 0 volt. This is why we need a pull-up resistor, 5 kilo ohm, 10 kilo ohm, 1 kilo ohm, doesn't matter too much. Now we have here a positive voltage, and we could connect the positive voltage to the input voltage. That is what I did on the breadboard. But then, unfortunately, this voltage will be 0 or 5 volt, and this is too much for our Raspberry. So we do not connect this to the input. We connect it to 3.3 volt. And now the GPIO gets 0 or 3.3 volt, exactly what we wanted. Here we have an assortment of switches, push buttons, very, very small push buttons for different usages. I wanted to have one of these. They are all PCB mountable, and sometimes you need one. For example, I needed one for my LoRa shield. There is a space for one of those tactile switches, and I never have the right switch, so I thought I buy a few of them, and now I have a little bit more choice. Here I have two boards which have a similar purpose. They are Lipo charging and protection boards. There are two of them for 7.2 volts, and I plan to use them together with the solar cells. This here has a input range up till more than 40 volts, and this one has only 9 volts. So this has a buck converter in addition just to the protection circuitry, and this is just the protection circuitry. So here we need a buck converter if we want to use it with a solar charger. Because I work now more with Raspberry Pis, I also have to work more with these small SD cards, and to not lose them I bought this small device, and here you have spaces for SD cards and they stick somehow in it so you don't lose them. You see here I usually label them with my label printer that I know what image I have on them. This is for the Pi 0 and this is for the Orange Pi, for example. And you do not have only one section, you have two sections. So it's 3 times 4 is 12, and here another 12. So this is sufficient for the next future, I think. These are power MOSFETs IRLZ44, N-channel MOSFETs, and I like the packaging here. They are in a TO220. I use them, for example, for the Raspberry Fan project, and they are just universal. They are logic level, so you can drive them with 3.3 volt microcontrollers or with 5 volt microcontrollers, so it's always good to have a few around of them. So I got some requests from viewers concerning the IRLZ44 transistor. They did not switch on at 3.3 volt, and I just want to check if I got fake transistors which might not switch on a logic level, but which would be then other transistors. So I connected my transistor to a fan, and I measure here the gate voltage, and here I measure the voltage across the fan. And we see now if I increase at 1.5 volt gate voltage, the fan does not work because it has only 0.6 volt. Now I go up to 1.8 volt, and still the fan does not work because it only has 0.77 volt. At 2 volt, still does not work. It has only less than 1 volt, and the fan will not work. It's a 5 volt fan. At 1 volt it will not work. At 2.1, still does not work. 2.2, still does not work. And at 2.3 volt it starts to work, and it has close to 2 volt now across the fan. So at 2.3 volt this transistor switches on, and if I go up to 2.4 volt gate voltage, we already have more or less the full voltage on the fan, and the fan blows already with full voltage. So this is definitely a logic level transistor which switches on way below 3.3 volt, and it can be used for any MPU with 3.3 volt. So thumbs up, these transistors are okay. These are stranded wires in different sizes. This is 26 gauge, this is 28, and this is even 30. It is always good to have several sizes on hand, because then you can select. And one thing is important here, they are silicone wires. They have a completely different touch and they do not melt. If you solder them, they have a very high melting temperature, and they are very, very flexible. So that's why I like them. And I have at least red and black for power, and maybe I will buy also a few other colors. But of course, if you have colors and sizes, then you quickly get lots of different wires. You can get them down to 14 or even 10 AWG. So these are then real thick wires. So from 10 to 30. Now, these very thin ones I only got in 1 meter quality. This is usually 5 meters, and the prices are really okay. The quality is okay. I like these kind of wires. There were some discussions about the supercapacitors in the last video about the Raspberry shutdown protector. This is why I bought now real protection boards to experiment a little bit with them. They are of course for these large caps, so they fit somehow, or should fit somehow, with these large caps, and they obviously have also a beefy, I think it's a MosFET transistor here, to protect these devices from over voltage. So I will have a look at it, where the cutoff voltage is and so on. But I will probably not use it with these ones, I will probably use it with smaller ones. But unfortunately I didn't find any protectors which are smaller in size. Here I have a few 5-volt fans for cooling, because these Orange Pi and Raspberry Pi CPUs get quite warm. We saw that, and I wanted to have some cooling fans to cool them down. I have a video in preparation for a variable speed fan to cool the Raspberry Pi. They are 5-volt, 0.2 ampere. Here we have a Raspberry Pi case with a cooling fan included here, and also the heat sinks. So it's a nice looking ABS, I think, is the material, and maybe this will also fit here. Let's quickly check. Unfortunately not. But if you cut off these two small separators, I think it would fit. No, it does not fit. Also the holes are slightly different. So we have the proof here. The Raspberry Pi and the Orange Pi PC are slightly different in shape. Just a small detail. Here we have an opening where we can get a flat ribbon cable in, basically to connect to the GPIOs. So this is a good concept, I think, where you do not have direct access, but you still can use the GPIOs just with a flat ribbon cable. I like this concept here. This is a sound card for the Raspberry Pi, but I'm not sure if this has really the right pin connections. I think we have to connect it through a ribbon cable, but it should be able to output sound from a Raspberry, but I assume also from a other microcontroller. Maybe I start to play around a little bit with sound, and I thought I get one of these to start with. These are called spade connectors, and they have quite an interesting concept. They have two parts, one here and one here, and they are made for this purpose. You enter a wire here, you close this one like that, and then you have to push here this small part, and now it's fixed. And then we should be able to connect this part here like that. And now let's try if we have connection. So we should have connection here and here. and we do not have. We have no connection. So let's check what went wrong. And we see here it does not work with these small wires. We have to have bigger wires. So you see already it's good to have several gauges here, and we can test this. We have already a connection here, so I put it on this end. So let's try here. Now it needs quite some force, and I use a plier here. Now let's check again. And now we have connection. It works with a 16 AWG wire. It does not work with this, I think, about 22 AWG wire. If we check now, we see that we have really a connection here where it's on the bare metal now. It's now metal to metal, and the connection was 0 ohms, so it was quite well connected. These can be used, for example, on a car or on a motorcycle. I plan to use this on my motorcycle because I have there a need where I have to have 12 volt for a different purpose for my GPS system, and I want to connect it to a existing wire, and I do not want to hurt this wire too much.
I hope this video was useful or at least interesting for you. If true, then like. Bye.